Good evening, everybody. It's Gaming Boy here for your tropical update for July 25th, 2020. I'm currently recording at 8:30 p.m. EST, and in today's video, we're mainly going to focus on Invest 92L, which could be a threat to the east coast of the United States. And Invest 92L could potentially become a major hurricane, and that has life-threatening effects for people who are going to get impacted by this system and needs to take notice about the system as it comes forward to the United States in the upcoming days. And so currently we're looking at the infrared satellite for Invest 92L. Center is currently sitting right here. See, very disorganized. And there's like barely any thunderstorms blowing up in your center, only like to the west of it and a few to the east of it, but really at this point it's like nothing at all. It is in a moist bubble. There is some dry air up to the northwest of the system, but that is not going to get entrained. It's probably some's going to get entrained in the center, but not a lot. It's in its moist bubble, as you can see with all these white colors showing up. Still pretty moist. Let me take a look at the true color, or not true color. I meant to do water vapor. I meant water vapor. As you can see, let me go to the last page. There is so much wrong size fat matter. You see, there is quite a lot of moisture surrounding the center. See right there. There is some dry air ahead of this thing, but that is to get like that's not to exist anymore here in like the next day or so. So yeah, taking a look at the model track guidance, you can see that they're all well in agreement that it's going to go somewhere north of the Windward Islands and could make its first landfall in Puerto Rico, or what's that? I don't know what the island is. I'm sorry whoever lives here, but I don't really know my geography that well, so it could make a landfall on this or this over here, Puerto Rico, basically. So it's gonna go this way towards the east coast, which is over here, out of the screen right now. And yeah, this is basically where it could turn a hurricane its first time. And if you take a look at that right here, we got models showing a tropical storm to almost a major hurricane, but this is so spread out yet. It's still so spread out, and it could turn to a tropical storm by tomorrow night, or on like how many, like Tuesday almost right here. So right tomorrow to Tuesday is basically where it could develop into a tropical cyclone that basically will have a model track, basically, yeah, forecast cone. I want it to come to tropical depression, which is down here. So it probably will become a tropical depression basically straight up a day from now, which is 8 p.m. EST. So 8 p.m. tomorrow, we could expect a tropical depression to form already by then. I'm wheezing for some reason. As you see, here's our system right here. It's in some neutral shear, as you can see in the yellow. It says neutral, and there's 20 knot shear going on. So it would not it's not favorable nor unfavorable for it. So basically stay the same. But this wind shear is soon to die down to these 15 and 10 knot winds, which is in the green, which stands for favorable wind shear, and this is where it will start get going and possibly form a tropical depression or storm by tomorrow. And it is to stay in this favorable shear for a little while before it gets to here. And I'll explain to you why that is and why is it helpful for it as well. So, taking a look at sea surface temperature, the system is currently sitting right here into some warm sea surface temperatures, as you can see with the 26 degrees Celsius, your 78 degree waters, 78 Fahrenheit degree waters, which is supports tropical cyclones and grows them to a tropical storm or Category 1 hurricane. So since this year, the sea surface temperature has been well above average, basically, to a degree Celsius above the long-term average. And since we have all this above average temperatures, we have all this warm waters up here. If this was an average, like a whole Atlantic wide basin average waters, it would probably be like way down here, and the system would go like these 25, 24 degrees Celsius waters. But since it's above average, the warm waters have risen north further than what it's supposed to be this time of year, and that's why the system has a chance to develop, according to National Hurricane Center forecast models. So taking a look at the ocean heat content here, you can see system right here, basically half 50 meters down and half 40 to 30 meters down. So see, sitting right here, the ocean heat content values here are supportive for a tropical cyclone to develop and get supported by this. And as I'm saying, this is your 80 degree isothermal depth. How far does the 80 degree Fahrenheit waters go down below the skin of the ocean? And so this is just going to bring up warmer waters as the thunderstorms develop where the cyclone would be. And so it's just going to keep upwelling warmer waters basically its whole life span, just going to keep getting more warmer waters. And you see this, going back at this page, you can see it's just 29s, 28s all across the board over there. See that? So it's basically, that's why this has a very easy time developing, as well as the MJO, I think. The MJO, the Madden Julian Oscillation. Basically, the oranges are your sinking air, and the greens are your rising air. So it's in this favorable era right now. So see all this green is all rising air, so convection will be easier to develop around the center of low pressure. And that's why this is also an easier time because of this. It's green. You have warmer waters. Did I just pull up? Yeah, so we have all this green wind shear up ahead of it. All this warmer waters as well right here. We have the ocean heat content, so it's in a very favorable environment ahead of its life, and also this green, so it's very favorable for it. And now we're going to take a look at the forecast models here. So 6 hours from now, forecast hour 6, here's our little system right here. Really nothing, like not that much thunderstorm, not that much circulation yet to it at this point. As we continue to a day out from now, we are now beginning to get thunderstorms, and now a circulation beginning to show up on here. Get some thunderstorms there. So now we're getting more thunderstorms around the center. And now move on to 2 days out. Now it really starts to get going. By this time, it looks like it's going to be a tropical depression or tropical storm with 1,005 millibars. Basically, now this is the point where it starts deepening pretty quickly, and move on to 3 days out. Maybe we can move on to like, basically, is this 4 days? Well, like close to 4 days. 96 is 4 days. All right. 4 days out right now. You see, well, let me zoom in real quick because those numbers are blocking. So as you can see, now it looks like it's a hurricane right here. So it developed pretty quickly beyond like hour 20, a day out from now to plus 3 days. So in 3 days, it developed to a hurricane, a full-blown hurricane right now. So yeah, so now this poses a threat to these islands over here. So I'll still clearly some of these because look how big the rain goes around the system. So basically, I'm gonna highlight all this. Let me highlight this. So basically, all you guys are gonna get impacted by the system, the ones I'm highlighting. All you guys have the potential to get impacted by the system. Like with the rain, some breezy conditions are expected with this, especially over here is where you get all your hurricane force winds possible along there. And as we move on to hour 132, shall we? See, it barely makes a landfall on these islands and goes north of it. 969 millibars. You can see that pretty quickly intensified from like right here to right here. Actually, pretty quickly intensified. And let me zoom back out and go to this quadrant. As we go over here, it does kind of weaken a bit, and I'll show you why. I actually told you guys can help it, but actually changed my mind. Actually, I'm gonna show you guys. It's with the wind shear and all. So as you see, it does make that approach to North Carolina coast. See, 962 millibars. This is like a Category 3 hurricane that could make a landfall in 960. Probably about to get probably like weak Category 3 hurricane beyond at this point, and it makes landfall and it enters through the very southeastern Virginia state line, and it goes out into the Atlantic Ocean once again, and it strengthens once more and gets carried out by a steering current, possibly a low pressure system up in in the northeast. Basically, it's gonna steer it out of the ocean. So now let's go start with the moisture. This is probably a video that's very long on one system. I'm trying to make these videos long and more information, give it more information. As you see, hour 48, and it's very big moisture bubble. There is some dry air up ahead of it and to the north and west of it, all up here. But I see the dry air tries to get through. The dry air down here tries to get wrapped inside, but doesn't get fully all the way there, and it just kicks it right back out of the system. And as you see, here's more dry air beginning to try to wrap inside, but the system is getting strong, and it insulates itself from the dry air and keeps it strong and moist. And switch places here. You see, here's our system right here, very moist bubble around it. Basically all hurricanes are associated with that. Most of them are. And there is still dry air trying to get wrapped inside, but it still fails to do so. This system is having no problem making its way through the Atlantic Basin, and it makes landfall as a Category 3 hurricane in North Carolina, near Wilmington. And yeah, well, when the model wasn't fully rendered, I thought I was about to do something like what Matthew was supposed to do, but didn't. I was about to turn back around, but no. So that's a good thing that it's just gone and get out of here, boy. So, yeah. Now move on to the part where we have our wind shear and all. So, beginning of its life right here, fairly, very favorable wind shear, but I don't know why that does not match up with this. It's neutral wind shear. This one shows like 0 to 5, not wind shear. It's not really matching up, but as you move forward in time, still, hour 24 has some moderate to high wind shear to the south of it. Could blow some thunderstorm activities to its west side a bit, southeastern side of it, while some thunderstorms can remain up here. Well, these thunderstorms that will form down here will get pushed over there. So that's why it is not formed yet. It once here. This is when this wind shear gets favorable. We're like, what? This is not favorable. It's green and yellow. Well, Hurricane Hannah had some wind shear And see this anticyclonic spin that basically helps with its outflow. When the thunderstorms build up around the center, the cirrus clouds will, all the bad air on the cirrus clouds will go out in this direction. Basically, it's just outflow. So it will basically, it's healthy at this point. And to continue, wind shear increases as well as the outflow. You can see basically these thunderstorm cloud tops would just go blown basically in an anticyclonic spin. So this will help it. But as we move forward in time, this is why I see like it was going down at 970, 969, but rises back up to 973. That's because the wind shear is not spread out equally beyond this area, so all of it's like focused up here, so thunderstorms are getting blown to the northeast side of it, so that's why the millibar rises up to 973 back again. Let's switch things again, and as you see, it equalizes back out, and that's why the millibars drop once more, and it makes landfall on North Carolina, goes through Virginia, and yeah, it encounters a lot of shear up here and land, which is hostile for it. And it deepens once more because once more again, this wind shear is spread out, and that is kind of good. Gee, that's why it deepened pretty quickly once it left the coast of Virginia, because all that anticyclonic spin is helping with the outflow, and it gets pulled back out to sea. Let me see if I can, my steering current's turning basically up here, because they're about to turn up there if I keep going. No, not. I see. Basically, it gets turned up here and it pushes the system into New England, and that's what that one calls for. That big, it's just a trough or a ridge. It's a trough. Basically dips back down, so that's why that thing is out of here. So that'll do it for this. I think it's long. I don't really have a sense of time. This court game is kind of boring me. So that'd be it for today's video. If you enjoyed it, drop a like. If you're new to the channel, subscribe. I'm doing way better than when I did my first video. I'm stuttering a little less. And I will talk to you guys later. Peace out.